So you have Kubernetes clusters. How many pods and deployments do you manage? Across how many Kubernetes clusters? How many environments do you maintain? With Kubernetes in the cloud, it is very easy to reach scale, and with Kubernetes at scale, the chances of misconfigurations are high. Now, to emphasize the issue, you've got to sit back and ask yourself, how many pods do you have? It's very easy for companies to start with around 5 or 10 and very quickly end up with a few hundred. How many of these hundreds of pods have health probes or memory limits? How many of these pods run as root and can potentially escalate privileges or even accidentally expose secrets? Maybe you don't even have visibility of your clusters, both from a best practice as well as a security point of view. Companies' number one priority is profit, and to make profit they have to prioritize features, and with that sometimes security and best practices take a back seat. And many may believe or feel like it might take a lot of time and it's too late to change the culture. But what if I told you that there are tools out there that can give you visibility on this and provide you with a roadmap that can address these issues? Today we're going to be taking a look at a policy enforcement solution called the Tree. Now there are many policy frameworks for Kubernetes, but what makes this one so special is that it provides you with a roadmap to follow best practices, especially for larger organizations that have many deployments where these types of changes may take time. Providing a roadmap gives you a strategy and a way to get there. You may have been using Kubernetes for many years, so your cluster is probably in a poor state. Let's see how we can visualize the state of our cluster and come up with a roadmap to evolve our best practices. So without further ado, let's go. Now to start off with this guide, the first thing we're going to need to do is install the tree. So if we take a look at my GitHub repo, I have a Kubernetes folder, and in the Kubernetes folder I have the tree folder with a readme of what's new with the tree in 2023. And in this guide we're going to create a Kubernetes cluster, we're going to take a look at the installation, and we're going to take the product for a spin. Now be sure to check out the link down below to the source code so you can follow along. Now the first thing we're going to need is to create a Kubernetes cluster, and for this video I'd like to use a utility called Kind. Now Kind is a lightweight utility that you can use to spin up lightweight Kubernetes clusters in Docker containers. It's very useful for testing because you can spin up multiple clusters on your machine and throw them away once you're done. To spin up a cluster, I'm going to say Kind create cluster. I'm going to name this one the tree, and I'm going to run Kubernetes 1.23. So go ahead, copy this, paste it to the terminal, and this will go ahead and spin up a lightweight Kubernetes cluster that we can use for testing. And you can see now my cluster is up and running and ready to go. And now what I'll be doing is running a lightweight Alpine container because I'm going to need a couple of utilities. Running things in a container helps make things portable so it can run anywhere, even on your machine. If you have these utilities installed, you can skip this step. What I'm going to do is run an Alpine container and install kubectl, a few Linux tools, as well as Helm. We'll be using the Helm chart to install the tree. So I'm going to create a lightweight Alpine container by saying docker run. I'm going to mount all my source code into the container. I'm also going to mount my home directory, the .kube folder, into the container because that is where the kubeconfig lives for my Kind cluster, or if I had a cluster in the cloud. Then I'm going to make my working directory /work. I'm going to run my container on my host network, and it's going to be Alpine with a shell terminal. Go ahead and copy that, paste it to the terminal, and now I'm inside a container. If I press ls, we can see all my source code that's here, that's on the left side. And now I can go ahead and install a bunch of utilities. Firstly, I'm going to install curl and JQ. Curl is a utility to make internet calls, so I can go ahead and download stuff, and JQ is used to manipulate JSON. Now with that done, I can go ahead and install kubectl. I just run curl, pull down kubectl, give it chmod execution permission, and move it to user local bin. Go ahead and copy paste that to the terminal, and that will install kubectl within my container. Now that that's done, I can say kubectl get nodes, And when that happens, we can see my Datree cluster has been created, and I can access it from within this container. I can also go ahead and install Helm, as we're going to need Helm to install Datree. I say curl, I get the specific version of Helm, I use tar to extract the tar file, and then I give Helm binary execute permission, and I move it to user local bin. It's the typical way to install Linux utilities. Go ahead and copy paste this to the terminal, and that'll install Helm. Once that is done, go ahead and clear the terminal, and we can just type Helm, and now you can see we have the Helm CLI installed. Now, to install Datree, I would always recommend the best place to start is the documentation. If we take a look at the documentation, you can see there's a getting started guide, and you can pretty much follow the document from top to bottom. It's very self-explanatory. You can see there's a quick start guide, how to install Datree with Helm, and then you're all set. So it's very simple. So the way I'm going to install it is through Helm. So what I'm going to do is add the Helm repo, say Helm repo add Datree-webhook. That's the name of the Helm chart. And here we give the URL to the Helm repository. Go ahead and paste that to the terminal, and that has now been added, and we can go ahead and search those repositories. So I can say Helm search repo Datree-webhook, show me all the versions. I go ahead and run this, and this is important because when installing Helm charts, you want to make sure that you're always installing the right version of this product for the right version of Kubernetes. So when I run this, you can see that there's all the versions listed down here. So to script this up, I'm just going to create some environment variables. So I'm going to download the chart version 0322, and the app version is 01.46. I go ahead and define these environment variables, and then the next one is my Datree token that I'm going to need. So this you can grab off the Datree website. Now there are a few ways you can get this token. If you go to the getting started page on hub.datree.io, or the link from my GitHub repo, and you go down here to the install instructions, you can see they talk about the Datree token, and you can just click this link to go to the dashboard where you can create a new token. Or you can go there directly by visiting app.datree.io. And then you want to head over to your profile page, and you can see there's a tab called Token Management. You can click into that, and you can just copy your token from here. You can also create new tokens. So what I'm going to do is I'm going to paste my token into this environment variable, and with that done, what I'm going to do is I'm going to create a folder to store this Helm chart. So I'm going to create a folder under Kubernetes Datree manifests. You can see that folder is already created on the left side here. There it is right there. And then I follow the instructions as per the getting started page, but instead what I'm going to do is say Helm template instead of Helm install, because I want to take a look at what this creates. So I say Helm template Datree-webhook, and then I pass in all the install flags and the options. So I say I want to create the namespace, so it's going to create a Datree namespace for me, and then I pass in my Datree token. I also set the cluster name. This is the name we can see in the dashboard for our cluster. You can give it any kind of name. You can see here I just use the current context of my cluster. So this will be called kind-datree. Then I give the version of the chart that I want to install and the namespace. And what I do is I just output those manifests to a file. So then you can use something like FluxCD or any other kind of CI/CD tool to deploy this. Or you can just change this template to an install and just install it directly using Helm. You can take a look at the documentation on how to install it here as well. If you want to go ahead and configure Datree, you can follow this link, which takes you to the configuration options that you can pass in. We'll take a look at that in a minute. So what I'm going to do is I'm going to take this command, copy it, paste it to the terminal, and that will use Helm to create the Kubernetes YAML manifest on the left here. And if we go through this manifest, it's very straightforward. It has a few service accounts that it'll use to run the webhook. You can see it also has TLS for the webhook, stored as a secret. It's got a few cluster roles, which gives it permission to read resources so it can do the scanning needed. It's got role bindings for obvious reasons. It's got a Kubernetes service to expose the webhook. And here you can see is the webhook deployment. It also comes with a job you can see called scan job. We'll take a look at this in a minute, but what this is used for is for scanning the cluster and forcing scans. It can run scans at intervals or on demand. So now that we have the YAML manifests, we can proceed to install it. So what I can do is say kubectl create namespace the tree, go ahead and create that namespace, and then apply the manifests inside that namespace. Go ahead and do that, and as you can see, that will deploy all the resources we've just taken a look at. I can check the install by saying kubectl in the tree namespace get pods, and when I run that, we can see there's a bunch of containers starting up. You can also see the scan job will start running as well, so we'll immediately be able to see our results. Give it a few seconds and we can see our webhook is now up and running, and all these OneSoft jobs are now completed. Now with Datree installed in our cluster, the Datree dashboard tells us exactly what state our cluster is in, and it gives our cluster a score. And the cool thing is it also shows you all the failing policies, and you can drill down to see the easiest ones to fix as well as the most complicated one. So you can go ahead and prioritize what to fix first and immediately start improving your cluster's standing. So now, as I mentioned, we can go ahead and view our cluster score, and I've put a link directly in this readme so you can jump to the dashboard. So this will take you to the app.datree.io page. And once you click that link, you'll go to app.datree.io/overview. This is the overview page where you can see your cluster score. So you can see the number of clusters you have, the number of checks that has been run. You can get a drop down with a list of clusters, and here you can see I have had a few playing around. You can see your cluster's version, the number of namespaces and objects, and when it was last scanned. And the cool thing is you can also run the scan on demand by triggering that job I showed you guys earlier. So you can go ahead and copy this command right here and run it in the terminal, which will trigger an on-demand scan. You can see we have a score D over here. All the failing rules are listed on the left and the passing rules are listed on the right. Now, if you wanted to add another cluster, you can simply hit this drop down and say add new cluster, and that'll show you the instructions of installing Datree. They're pretty much the same instructions we've used earlier. So you can install Datree on different environments. Now, the cool thing is the overview page allows you to drill down into these failing rules to see which pods and deployments are failing these policy checks. So you can either click into these, which will take you to the drill down page, or you can access the drill down from the left here. If we access the drill down page, you can see we have all the lists of failing rules. And you can see these failing rules are coming from one namespace called local path storage. I can also see that on the overview page by hovering over the failing configurations per namespace. Now, we've just gone ahead and created a brand new cluster, and this namespace does not really belong to us. It's pretty much a system namespace that is used by Kind. Now, it's generally going to be the case that you're running Kubernetes in the cloud as a managed service, or you're running Kubernetes on-prem and you need a bunch of namespaces and components to run Kubernetes on-prem. And for both cases, you might also need some open source components like Prometheus and Grafana or Fluentd for logs and metrics. Some components that you might not have control over. In our case, how can we just simply hide or skip this namespace? Now, there's two options that Datree gives us. We can go ahead and annotate or label namespaces and objects to tell Datree to skip them. This can be done by saying kubectl label, labeling that namespace with this label. It's admission.datree validate equals skip. So I can just simply run this one command and automatically skip that namespace if it's not important to me. Or a better practice is to use the Datree config map. And we can do this by using the configuration file that I've linked here. If we click into this, this takes us to the configuration page. It's on the left under behavior, and you can see here is how to ignore a namespace. You can label the namespace, or we can go ahead and define a config map to do some custom skipping. Here you can write regular expressions to skip certain namespaces or certain objects within namespaces. Like here's an example that will tell Datree to skip all resources of type service account. So maybe you you only want to skip service accounts or specific types of objects, you can do that using the config map. I've gone ahead and created in my Kubernetes Datree folder a configuration folder, and I have config.yaml here. This is an example where I say I want to skip the local path storage namespace. And as you can see, there are 3 parts to this. The namespace, then the resource kind, then the resource name. So here you can see there's a regular expression to say all namespaces, then the resource kind, and then all names under that. So this will be all service accounts and all namespaces. In my example here, I say a specific namespace, and then I say all resource kinds and all resource names. So this will skip everything in the local path storage namespace. So to deploy that change, all I need to do is say kubectl apply and apply that config map.yaml in the Datree namespace. I go ahead and run that. That'll create a new config map. And to apply the config map, I need to just do a rolling restart of Datree. So I go ahead and run that. That'll restart the Datree webhook controller. Now, according to the dashboard, we still have a D score. Now, to update that, we need to run a manual scan. And to do that, I can just copy this command here. So I say copy, go to the terminal, paste that one, and that'll create the scan job and kick it off. And if I give it some time and I refresh this page, we can now see our cluster has an A score, and it has recently increased. Now we don't have any failing rules, and all our rules are passed. Now, it is highly unlikely that your environment will be as simple as this, because this is a brand new cluster starting from scratch. And it's very likely that when you look at your dashboard for the first time, it might be a D grade or worse. And it is unfortunate, but it's very real that Kubernetes implementations and a lot of companies are insecure by default. For example, if you look at containers, by default they run as root. And if you look at simple Helm charts and example YAML files for deployments, they don't always follow best practices. So it's very easy to lose out on this. And the challenge is that most engineering teams are simply trying to get things done, which is understandable. But the problem is security and best practices take a back seat. And when you realize it's a problem, it becomes a gigantic task to fix it. And it's not always easy because you may have distributed teams who all have different skills and roles. A front-end team understands HTML, CSS, JavaScript, and all the front-end frameworks. A back-end team understands things like Node.js, C#, Go, or Python. And perhaps another team understands networking or databases. It's not always easy to shift left overnight. Now, what I'm going to do is deploy a bunch of complex systems to our cluster, and then take a look how Datree gives us a roadmap for tackling these issues. So you can go from a low grade to an A grade. So what I'm going to do next is deploy some workloads to our cluster. And what I'm essentially trying to do here is deploy a bunch of workloads to simulate a real cluster. And the interesting part here is that I took very basic systems that a lot of companies use, like MySQL and WordPress, and I took these YAML files as Helm charts off the internet, just like other people would do. And these are very basic implementations, like a namespace, a config map, a secret, services, stateful sets, and deployments. So what I'm going to do here is create a new namespace called CMS. I'm going to deploy a CMS website. I'm going to create a config map for MySQL as a backend. Go ahead and create that config map. Then go ahead and create a secret for WordPress, the CMS site, that'll allow it to connect to MySQL. Go ahead and run that. Then I will also create a new secret for MySQL indicating the default username and password. Go ahead and run that. And then I'm going to apply all these YAML files under the Kubernetes Datree example CMS folder. Go ahead and apply that. That will deploy a deployment, an ingress, a service to expose WordPress, a service to expose MySQL, as well as a stateful set for MySQL. You can find all these example configurations under Kubernetes Datree example CMS. There's a deploy YAML, ingress YAML, service YAML, stateful set YAML. And to check out these workloads, I can just say in the CMS namespace get all. When I run that, we can see MySQL is coming up, as well as 2 pods for my WordPress site. Now, with these resources running, what I'm going to do is run the Datree scan job again. So we're going to rerun our scan. That's the same command I just copied from the dashboard. Go ahead and kick that off. And then I wait a couple of seconds, I go here and I refresh this page. And when I refresh it, we can see we're back to a D score. So this is most likely what one of your clusters would look like. Now, what I wanted to show you is how do we come up with a roadmap to fix these issues. Now, there are two types of issues here. Some are very easy to fix, and you might have teams that can just jump on these and fix them straight away. Other ones are more complex to fix and might take time. Now, you can either drill down into some of these that might interest you, and you might know what is easy to fix. So you can just click on this and then see what you can fix. Or you can go ahead to the drill down page, and this will provide you the list of all the failing rules as well as the complexity to fix them. So you can see here we can go ahead and pick some of the easy ones to get the low-hanging fruit. So the tree tells us to fix complexity. We can go ahead as developers and go through this and go, okay, I can pick this very easy one because this kind of makes sense to me. You can click this and it will also tell you what it means. So it tells you the rule impact. So this one talks about ensure that each container has a pinned version in its tag. So if I run a YAML file for WordPress and I just say I want to run WordPress as an image, there can be certain impacts to my system. Here it says when the version tag is missing, every time that the image is pulled, it pulls the latest version, which may break your code. So in our case, every time the image is pulled for WordPress, we can potentially pull a latest version of WordPress. So if there's a major upgrade to WordPress, it could cause our CMS to break. So it's always best practice to pin the version. It also tells you how to fix this. So incorrect key for image, specify an image version to avoid unpleasant surprises in the future. We can also click the open docs section. This will link us to the Datree document, which goes into much more detail describing the policy as well as the complexity and how to fix it. So here you can see in our YAML file, we say containers app images Nginx. So this will always pull the latest version of Nginx. So if today you start on version 3, think about like maybe a year down the track, the latest version is version 5. This might cause very undesirable results. Generally, if you don't have a tag, latest is always assumed. Or if you specify latest like this, it'll just pull the latest all the time. And look at how to fix this. You basically want to pin the version that you're interested in. This means you'll always pull Nginx 1.19.8 instead of latest. So what I can do is I can go to my WordPress YAML file and I can see here that I'm pulling the image WordPress. I can go ahead and pin the version that I actually want. And I've put the example summary of all our fixes in the README file. And in this case, what we do is we're just going to pin a version, Apache, and that'll fix that issue. So you can see this is very easy to pick up and just start fixing. So when you're prioritizing a roadmap, you might pick some of these as easy pickings and create action items for your teams just to address them as soon as possible. As you can see, these changes might take a few minutes of your time. Now, some of these issues are shown as hard, which might be a little bit more difficult to fix, like adjusting the pod's memory limit and request values. This is because as a developer, you might not know how much memory is available in the platform. You might need to consult people who are in charge of the platform to see what sort of limits you can put in place. Hence, it's marked as hard. If we click that, we can see that there's an impact to this policy. Without memory limits, pods running in your cluster will not have a restriction on the max amount of memory. So this may cause out of memory failures, which can disrupt other pods running on the same node. We can click the open docs section and it tells us exactly how to fix it. You can see just by putting a limit here for memory in our YAML file, we can fix that issue. So when you're building a roadmap, you might need some teams to communicate with others to figure out what the memory limits might look like. I have an example here for the WordPress site of the memory limits and request values that I'm going to be putting in place. So I go ahead to my deployment and under my container, I'm going to go ahead and apply these limits. I'm going to put it under here and I'm just going to put a 500 megabyte memory limit and request value. And then I'm just going to go ahead and fix these last two easy ones for my WordPress site. Is prevent containers from escalating privileges. If I click that in, I can see that a container container, in its default state, containers allow privilege escalation, and attackers may use this to manipulate the application and get more permission than what they should have. So there's just a key in the YAML file to say allow privilege escalation, and we set it to false. If we click into the docs, the documentation tells us exactly how to fix this issue, putting a security context with allow privilege escalation to false. That's privilege escalation. The other one is ensure the container has a read-only file system. So I click into that. An immutable root file system prevents attackers from being able to tamper with the file system. So if there's a vulnerability in WordPress, attackers could use the file system to write foreign executables to disk, so they can actually create a backdoor. So we can prevent this by adding the read-only file system and set that to true. If we open the docs, we can see exactly how to fix this issue with the security context. So I have an example here. I'm going to take the security context, go to my WordPress site, set the security context, and then I'm going to apply these two values. So I go ahead and paste them. The one is allow privilege escalation set to false, and the other one is read-only file system set to true. Now there are two other ones that are important as well. One is each container must have a readiness probe configured, and the other one is each container must have a liveliness probe configured. Now because I'm a developer of this WordPress site, it could be simple for me to add a liveliness probe, but this one is also marked as a hard complexity because as platform engineers or DevOps engineers, we may not know if the application has a health probe endpoint, and sometimes it might require a code change for a developer to add a health probe endpoint for you. In this example, to get around this, I'm just going to use the home page as a URL because I don't have a page to show at the moment. If you click onto this and go to the documentation, it again tells us exactly how to add a liveliness probe. I've again got an example for my YAML file on a liveliness probe as well as a readiness probe. And I would always recommend for the development teams to specify a health probe URL. So go ahead and paste that and add our liveliness probe as well as readiness probe. And now we can go ahead and apply our YAML files. So I'm going to say kubectl in the CMS namespace and apply the YAML file. Go ahead and paste that to the terminal, and that will go ahead and update my WordPress site. And then what I can do is I can run that scan job again and wait a couple of seconds. And if I go back to my overview page, you can now see my cluster is in a B grade. So we've improved our cluster score by picking up the low-hanging fruit, drilling down into our cluster, picking the easy items and resolving them using the dashboard as well as the documentation. Now, how do we solidify these changes? Part of building a roadmap is to ensure that these sort of problems don't happen over and over again. So when we put in this effort to solve all the easy issues, and some of them might be a little bit more tricky, we want to make sure that our cluster stays in a B score grade. And we want to ensure that our WordPress site doesn't degrade further. This methodology will help improve your cluster's score over time, because all the effort you put in will make sure that the cluster score only goes up and prevent things from slowly going downhill. Now Datree allows us to achieve this by integrating with the CI/CD pipeline. So you can hook up Datree with all of these different types of CI/CD workflows. So with our WordPress site now updated, we can go ahead and add Datree to our WordPress CI/CD workflow and make sure that no bad practices are applied to our cluster. So as an example, we can take a look at the GitHub workflow, and this shows how to integrate Datree with your GitHub CI/CD pipeline. So you simply add a step in your CI pipeline where you can run Datree against YAML. So what I've done is I've created an example under Kubernetes Datree. I've created a GitHub Actions folder with a datree.yaml. So you can see this is what it looks like. You pass in a standard GitHub Action YAML file, but you have to have your Datree token, and then you simply add the check wherever you want. So what I'm going to do is I'm going to do it just after my code checkout. So I'm not going to have my build and test and all of that sort of stuff run if there's a problem with the policies. And if we take a look at my GitHub Actions, we can see that I tried to push some new change to my WordPress site, which potentially would have degraded. And if you click into that, you can see there's a K8 policy check that has failed. That is the step that I just showed in my GitHub Action pipeline. If I click into that, we can see that the tree failed its policy, and it gives you all the policy checks that have been failed. So this is very useful in preventing misconfiguration from reaching your production site. Now, the cool thing by integrating the tree in your CI/CD pipeline is that we're not preventing and blocking other development teams from deploying stuff to production. So in this example, my MySQL instance can still have its deployments ongoing. We simply addressed the WordPress site. So by picking services one by one and adding them to the pipeline, it'll gradually improve the score of your cluster over time. So I also wanted to mention that if a developer is working locally on the WordPress site, they can also check the policies locally by running the tree. So this is very simple because the tree also comes as a command line. I can say curl get the tree.io, pipe it into bash, and that will go ahead and install the tree locally. So here you can see I have the tree now, and I can say the tree, and it tells me how to run the tree here using the command line. And it's very simple. To test my CMS to see if I broke anything, I can say the tree test and then pass in the YAML files. So you can see here I pass in Kubernetes, the tree example, CMS star.yaml. So I pass in everything, run that, and we'll get output immediately. So you can see I can run it locally and I'm still getting failures on my stateful set, which is MySQL. So we fixed all the WordPress stuff, but we haven't fixed MySQL. But this shows you that you can run this locally, so it helps you address issues on your local machine before going into your pipeline. The tree can also run as a VS Code plugin, which is built by the community. If you want to see a lot more about the tree, check out my link down below to my introduction to the tree video, which goes more in depth on the CLI as well as testing Helm and customized templates. So now we've initiated our roadmap by taking bits and pieces of our platform, slowly improving them, and then adding guardrails in our CI/CD pipeline to prevent these items from going backwards. Now there might be a lot of components that are not always looked at, and microservices that only get updated once every few months. How do we address some of those? Now the tree can also enforce policies on the cluster itself. So rather than blocking at a CI/CD pipeline level, we can actually block at a cluster level. So let's say we've spent a lot of time to ensure that all our services now have health probes. We can go ahead and enforce these policies at a cluster level to ensure all services that are deployed to the cluster must have a health probe. So if we turn on enforcement within the tree, it'll give us a method to progressively enforce policies so that when services are deployed over time, they have to comply with these policies, which means our cluster's grade score improves over time. Let's take a look at how to enforce these policies. So if we take a look at the documentation under behavior, which is under the configuration section, we can see that there's an option to enforce. So we can block all resources that fail a policy check from being applied to the cluster. To do this is very simple. They're all used by setting Helm flags. So we can run Helm upgrade and simply set the flag. So we set the tree.enforce to true. And there's a full list of configurable parameters of the Helm chart over on the GitHub site. Now, if we take a look at my README guide, I have a section on how to enforce these policies, following the same document we saw earlier. So you can run the Helm upgrade command and pass the set flag and set the tree.enforce to true. So what I've done is updated my Helm template command and simply added the line where I set enforce to true. And then what I do is I'm actually just going to create another YAML file as an output so we can see the change. So what I'm going to do is I'm going to go ahead and grab this, copy it, paste it to the terminal, and that will now generate another YAML file on the left. And if we take a look at the YAML file, the only real difference it has made is set the tree enforce environment variable to true on this tree webhook server. So this will now enforce policies when things are applied to the cluster. So to deploy those changes, I'm just going to go ahead and apply that manifest, and that will deploy the changes. And to test these changes, what I can do is just try to deploy MySQL because we know that we have not fixed the policies on that one yet. So if I go ahead and run the kubectl apply on the stateful set.yaml, we will see that the tree has now intervened. And we can see it's done the policy check on that, and here are all the failing policies that it's come back with. So now by enforcing these policies at a cluster level, we should be seeing gradual improvements to our score over time, as teams will need to comply with these policies when they roll out changes to their software. So this means we can now start enforcing these policies on our platform. And as you can see, the tooling provides a lot of mechanisms for slow, gradual rollouts, which helps larger organizations or even more complex Kubernetes environments where changes are not that easy to roll out. So you can make slow and steady gradual improvements for both security and best practices, instead of having your clusters degrade over time. So I hope this video helped shed some light on container best practices. And remember to check out my introduction to the tree video down below. And if you liked the video, be sure to like and subscribe and hit the bell. And if you want to support the channel even further, be sure to check the Patreon link down below or hit the join button to become a YouTube member. And as always, thanks for watching, and until next time, peace.